Hello everyone, my name is Tim Hansen, and today I'm going to be covering firmware updates for Sophos UTM on AWS. So this video is the second part to the Up2Date for Sophos UTM on AWS series, and it's going to explore what happens to our running UTM instances once we actually initiate the updating process. So ultimately, how do new instances with the latest firmware get created, and really what's going to happen to my current instances that are running with the soon-to-be old firmware, or even potentially what happens to my Elastic IP address, which may be handling user traffic at the moment. How's that going to get transferred over, or more importantly, when is that going to get transferred over to the new instances? Now, in the first video I recorded in the series, I explained the various deployment types for UTM on AWS. So the differences in deployment types is important to know in this video, much like it was in the previous video. So I'll just do a quick recap of them now, just so there's no confusion when I refer to something like auto-scaling versus something like auto-scaling with the outbound gateway. Okay, so once again, we effectively have 5 different deployment methods for Sophos UTM on AWS. The first is, of course, the oh-so-lonely standalone UTM instance. And then here we have a high availability deployment, which is available either in cold or warm standby. Number 3 is an auto-scaling deployment, so maybe a controller, or as it used to be called, a queen, and 2 or more worker nodes. Number 4 would be if you deployed auto-scaling in one step or through one Cloudformation template, and then as a completely separate step or a separate Cloudformation template, also deployed the outbound web gateway. And then number 5 would be if you deployed auto-scaling and the outbound gateway, as well as the Bastion host and a few other running instances, altogether using the AWS Quick Start template directly from the Amazon webpage, as you see here. All right, now what's going to happen once we've gone into Cloudformation, uploaded the new Cloudformation template, or maybe even provided the URL to the S3 bucket that the new template is stored on, and then gone ahead and click the update button? How will running instances be affected? How will new instances with the latest firmware get fired up? What you'll see here as I go through the flow of each deployment type is a sort of pattern on how the old instances get turned off, how the new instances get fired up, etc., etc. So even though each deployment type has its minute differences on what happens when you run Up2Date, you'll get to noticing that essentially the process ends up being the same, regardless if you are using HA or auto-scaling. So first, let's look at a high availability deployment in cold standby. For HA cold standby, it's reasonably simple. You have one instance running in one availability zone, and when you update the stack, a new instance is going to get fired up in the second availability zone / subnet. And this new instance is, of course, going to be built from the updated AMI and thus have the new firmware on it. So once this instance is fired up, running, and passes its AWS health checks, it's going to pull the configuration back up from the S3 bucket, restore it, and at that point make an API call to AWS, which will move the Elastic IP address over to it. Once this is completed, the old instance is effectively dead weight and it serves no use to us, so it gets terminated. That's it. The update is completed. Nice and easy. For HA warm standby, you of course now have 2 instances running, one in each availability zone or in each subnet. One node is going to be the primary node that handles traffic, and the other one's going to be sitting off to the side, effectively just waiting to be called into action. Once the stack update is underway, the standby node will get terminated pretty much at the same time that the new master gets created. And then similar as we saw before with cold standby, once the new master passes its health checks and such, the Elastic IP will be moved over to it. Once this is done, the old master will terminate, and then a new standby node will get fired up. That's pretty much it. Again, pretty straightforward, similar to cold standby. All right, so now we've covered high availability in both cold and warm standby deployments. So let's go ahead and look at how the Up2Date process works now for auto-scaling. In an auto-scaling environment, you would typically have one controller, or as it used to be called, a queen, and then at least 2 worker nodes. There may be circumstances where you might have maybe more than one controller, or more than likely more than 2 worker nodes. So if that is the case for you, just use the flow I'm going to explain here for a single controller and 2 worker node environment, and then apply it to your specific setup. The steps are pretty much the same regardless of the number of controllers or workers you may have. All right, so when you apply the update in an auto-scaling environment, the first thing that's going to happen is an additional controller instance will get launched into the second controller subnet, which of course is in the other availability zone. And then similar to HA, the elastic IP will get transferred over to the new controller once it passes its health checks. And at that point, the existing controller can terminate. Right after, or even maybe while the controller is terminating, another worker node will be in the process of getting launched into the other worker subnet. And then once this worker is up and running, its opposite in the other availability zone will terminate. And at that point, the process will kind of just repeat itself until all the worker nodes are replaced. Pretty straightforward. And I'd be willing to bet at this point you can see a sort of pattern developing when it comes to the process that the environment, regardless if it's HA or auto-scaling, goes through to update the instances. Now, if you're using the outbound gateway with auto-scaling, like I explained in the first video, you'll need to replace the gateway, or the instances, I should say, separately through their own Cloudformation template. And in my experience when updating the gateway, it just kind of blows away the old instance and then creates a new one as a replacement. It doesn't necessarily go through the same nice process of waiting until health checks pass, etc., before terminating the old one. So just keep that in mind. If you are updating the outbound gateway, do plan for a few minutes of downtime. Now, for quick start auto-scaling deployments, so if you have the UTM or the UTMs, the outbound gateway, the bastion hosts, etc., all mashed into one, the updates for the UTM portion of the process, so for the controller and worker nodes, will work exactly the same as I just explained for regular auto-scaling. It'll follow the same process of bringing up additional nodes, and then once the health checks are passed and the elastic IP is moved over, terminating the old nodes. For the additional instances, such as the outbound gateway instances or the bastion host, these will also go through the same process of getting replaced, but unlike the controller and worker nodes, it doesn't have the graceful exit, like I explained previously, of ensuring the new nodes are running before terminating the old nodes. So just keep that in mind again to plan for downtime. Now, I will make mention of one thing when it comes to the outbound gateway instances. Because the instances get replaced with the new AMIs, if you've made any customized changes to any of these instances, whether they be operating system or software updates, custom scripts, cron jobs, whatever it may be, these changes will not persist through the update, and they will need to be reapplied once the new instances do get fired up. All right, excellent. So that's it in a nutshell. And as you can see, it's a fairly logical flow when it comes to replacing instances. And it really does do a good job of minimizing downtime in environments that can afford very little downtime, or maybe only have small maintenance windows to do these sort of things. So with that said, that about wraps up this video. I will say thank you for watching. If you do have questions or comments, leave them below. Otherwise, we will see you next time.